Hi guys, so I downloaded Stockfish here and I'm going to run this command called perft. It's going to count all of the positions reachable from the start position at depth 7 using one thread. So Stockfish mainly just uses this command to test the correctness of move generation. And it doesn't use a transposition table by default. Okay, so we got like 26 seconds. Let's compare against the code that I wrote called Temple Chess. So this is using the exact same algorithm that Stockfish is using, and we'll discuss ways we can actually make that faster in a second. Okay, so about 12 seconds. So let's open Paint. Okay, so here I've got a graph, and I'm going to let each vertex on the graph represent a chess position, and each edge is going to represent a move in that chess position. I've also labeled the depths starting from 2 and decrementing until 0. That's just arbitrary. You can start at 0 and increment until 2. It doesn't matter, but it's just easier to do it like this in the code. So we want to know the number of positions reachable from any given position. So we need to know how many positions are here, because these are all of the leaf nodes or vertexes. Same thing. So you'll notice that we've got 4, 7, 10 leaf nodes here, and we've also got 10 moves. So to count all of these positions, all we need to do is and this is all that Stockfish does. All that Stockfish does is it goes to depth 1, generates a set of moves here, and adds the size of each set at depth 1. It doesn't actually go to depth 0. So if we look at what that would look like in code, so this is how I've implemented that algorithm in code. So I generate a set of moves. If we're at depth 1, we return the size of the set. Otherwise, we keep traversing through the tree recursively. You can see that I decrement the depth here, and I call the same function recursively. So if we go back, so one thing we can do is that instead of actually generating these set of moves, we can take that a step further and we can just directly go to depth 1, and instead of generating a set of moves, we can just count the number of moves in the chess position directly. So this would be 3, 3, 4. So how that would look like in code would be, so instead of generating a set of moves, I'm just going to directly return the number of moves in the current chess position. Like this. And then if we're not at depth 1, we can generate a set of moves. So let's recompile. And let's see how fast it is now. Okay. Let's run that again. Oh, sorry. Yeah, that's correct. Yeah, so it's like, what did we get before? Like 12 seconds, so it's like 50% faster. If we go back to Paint. Okay. So another thing we can do is, let's say at depth 2, let's say these two moves aren't going to affect the next set of moves. Right, so if these two moves don't affect the next set of moves, that means these two sets must be exactly the same. Which means we're just doing unnecessary calculations if we're computing the same set of moves multiple times. So what we can do is we can just compute this set once, and we can just remove these moves from the set at depth 2, like this. And we count how many moves that we removed from the set, then multiply that by the single set that we calculated for the next set of moves. So in this example, that would be, we removed 2 moves, and the set of moves had a size of 6, so you multiply that, you get, sorry, the set of moves had a size of 3, multiply 2 by 3, you get 6 at depth 2. And we don't even bother, for those moves, we don't even bother searching them to depth 1. So let's see how that's implemented in code. Okay, so I'm going to go for a depth 2. I'm going to implement the algorithm, and we're not going to return because we still need to search some moves to depth 1, but we're just going to add that number to the total number of nodes, and this function is going to remove those moves that we talked about from the set also. So now if we recompile, and we see how fast it is again. Okay, so again, like, that's another 50% speed improvement there. So I'm gonna leave a link to the code in the description of this video. Feel free to check out the code. And let's also have a look again at what Stockfish's original time was. So about 26 seconds. So about 5 times faster than Stockfish. Obviously not a fair comparison because Stockfish wasn't built for just counting chess positions, but still a good benchmark to test against. Feel free to check out the code, see if you can find improvements. I'm sure there's more improvements that can be made. And if you find anything, feel free to make a pull request and I'll definitely check it out. Thanks for watching.